This is the Unit 2 Trig review, problems number 14, 15, and 16. So number 14 says, express the sum or difference as a product of sines and cosines. Cosine of 7 theta minus cosine of 3 theta. So we got to find the formula that matches up with that. And it says cosine alpha minus cosine beta equals negative 2 sine alpha plus beta over 2 times sine alpha minus beta over 2. So all we're going to do is plug in the values. So negative 2 sine alpha is going to be 7 theta and beta is going to be 3 theta. So alpha, once again, was 7 theta plus beta, which is 3 theta, all over 2. Times sine alpha, which is 7 theta, minus 3 theta, all over 2. So reducing this down, I get a negative 2 sine 10 theta over 2 times sine of 4 theta over 2. If I reduce this down some more, I get negative 2 sine of 5 theta times sine of 2 theta. That answer corresponds to letter C on the answer key, and here it is. Okay, so that was number 14. Let's go ahead and take a look at 15. 15 reads, express the product as a sum containing only sines or cosines. Sine 5 theta, cosine 6 theta. So we have to find the formula that works for that one. And it's going to be sine alpha cosine beta equals 1/2 sine alpha plus beta plus sine alpha minus beta. So we're going to plug and chug the values in. And before we do, we have to note that alpha is 5 theta and beta is 6 theta. So I get sine alpha, 5 theta, plus beta, which is 6 theta, plus sine alpha, 5 theta, minus beta, which is 6 theta. And now what I need to do here is reduce this down. So I get 1/2 sine of 11 theta plus sine of negative theta. Now, hopefully you remember I can't leave this way. Sine is odd, therefore the negative is going to come out. So I write this up as 1/2 sine of 11 theta, because that one was fine, minus sine of theta. So once again, I used the even odd properties to take care of that. And this is my answer. And that answer corresponds to letter C. Alright, so let's look at number 16. Rewrite over a common denominator, 1 over 1 minus cosine theta plus 1 over 1 plus cosine theta. Notice that both of those are binomials. So to find the least common denominator, we have to include both binomials, 1 minus cosine theta times 1 plus cosine theta. My next step here is to write each one of these having the correct denominator and build it up. So I had 1 minus cosine theta. I also need 1 plus cosine theta. I had a 1 there before, so now I have to put what's new, which would be this, in the numerator. Okay, plus. I had a 1 in the numerator and I had 1 plus cosine theta. To make it a common denominator, I need to include 1 minus cosine theta. So that's what's new. And being that said, I have to bring that up to the numerator as well. So, in the numerator, I get 1 plus cosine theta plus 1 minus cosine theta all over 1 plus cosine theta, 1 minus cosine theta. Alright, let's combine like terms in the numerator. I get 2 over 1 plus cosine theta, 1 minus cosine theta. Now, if I FOIL that out, or if I notice those are the difference of perfect squares, the answer is going to be 1 minus cosine squared theta. 2 over that. And you'll notice that the answer key doesn't look like that because they want you to use the Pythagorean identity. Just as a reminder, sine squared theta plus cosine squared theta equals 1. So if you get sine squared theta by itself, I get 1 minus cosine squared theta. So what I'm going to do is substitute in wherever I see 1 minus cosine squared theta with sine squared theta. And there's your answer. So that was a free response, so the answer is 2 over sine squared theta.